Hello everyone and welcome to High Performance Joint Firestopping.
This webinar is sponsored and presented by CEMCO. My name is Tan Nguyen, AWCI's Education Program Manager. At this time, I'd like to introduce our presenter, Jaime Manzo. Jaime is responsible for sales and technical support of CEMCO's Firestop product line. His role includes technical support of CEMCO's fire, acoustic, and smoke joint products across the construction industry. Prior to joining CEMCO, Jaime spent 5 years in the industry promoting code-compliant products and training contractors on best practices. His prior experience also include providing technical assistance for one of the largest drywall manufacturers. So welcome, Jaime.
Thank you, Tao, for that introduction. I'd like to welcome everyone to this Firestopping presentation today, and I sincerely appreciate all you taking the time to be here today. So I hope the session gives a solid overview of some of the related codes as they pertain to fire-resistant joints. And today we're going to cover testing standards and methods, as well as product solutions. So we're going to take a look at older first-generation solutions and newer next-generation options when it comes to joint fire stopping. So with that said, let's just go ahead and jump in. So setting expectations up front, this presentation style isn't going to be a word-for-word reading of the slides. I'll be speaking more to the main ideas and keeping things a little more relaxed. So if I skip over something, or if you have any questions you'd like to dig into a little more, feel free to drop them in the chat box and I'll make sure we get to them at the end of the presentation. So the goal today is to walk you through a range of ideas with the hope that you'll be able to identify, discuss, and perhaps even apply some of what we cover. Now, some of this might already be familiar to a few of you. However, other parts might give you a new angle or provide some practical solutions. Either way, I hope you do find the session valuable. Now, for this presentation, I want to focus on 3 main types of joint applications that you'll typically see in interior rated gypsum board assemblies. So joints are designed to accommodate movement, and that movement can be due to forces such as dead load or live load, thermal expansion or contraction, wind, or seismic movements. Now, specifically, we're going to be looking at the head of wall, bottom of wall, and wall-to-wall joints. So let's use head of wall as an example. This type of joint is going to allow the floor ceiling assembly to move without damaging the wall assembly, and more specifically, the drywall itself, which contributes to the fire resistance rating. Now, in a typical head of wall application, you often see an interior fire rated partition, meaning either a flat concrete deck, or as you can see here, a fluted metal deck. So when it's a fluted metal deck, the gypsum board is usually cut to match the profile of those metal flutes, or what we commonly call castle cut. Now, when we're talking about the gap between the top of the drywall and the bottom of the deck, the International Building Code, specifically 715.1, refers to it as, quote, joints and voids in or between horizontal and vertical assemblies, unquote. Now, what I want to emphasize here is that the fire-resistant joint systems are specifically designed to protect those gaps between the different parts of the assembly. And throughout this presentation, I'm going to be referencing UL and ASTM standards that are focused on exactly these types of conditions. So let's build on this. When we talk about fire-resistant joints, the key requirement comes from AWCI section 715.1. Now, this section sets the baseline that all fire stopping manufacturers have to meet when developing systems for these types of applications. So as I mentioned earlier, these joints are located between fire-rated assemblies, and whatever solution is used must be part of an approved system, both in terms of how it's designed and how it's installed. Now, when it comes to fire ratings, the joint itself has to match the rating of the adjoining wall or floor. So take, for example, if you have a 1-hour rated wall connecting to a 1-hour rated deck, then the fire-resistant joint at that intersection also needs to provide at least 1-hour rating. So looking at the images to the left, you're going to notice a few different joint types. So going clockwise, you're going to see gypsum wall meeting the underside of a deck, then a floor-to-floor joint, a floor-to-wall joint, and then lastly, a concrete or masonry wall meeting a concrete deck. Now for this presentation, we're going to be zeroing in on the top right image, specifically head of wall, bottom of wall, and wall-to-wall joints where frames and partitions connect with the surrounding structure. So you might be wondering, why all the fuss about fire-resistant joints? And at the end of the day, it really does come down to meeting specific building requirements. Now, the IBC lays out very specific rules for how buildings should be designed and built. And those rules are based on things like occupancy type, construction type, and how the spaces are going to be used. The code spells out what kind of fire resistant ratings are needed and what kind of performance is expected for different building components, including the joints. Now, before we move on, I want to think about one question. What is the leading cause of death in a fire event? Your first instinct might be to think, well, say the fire itself, but it's actually not the case. The leading cause of death is inhalation of smoke and toxic gas. So what's surprising is that even though this is widely known, the current fire resistant testing standards for joints do not include smoke or toxic gas containment as part of the pass-fail criteria. Catches a lot of people off guard. So there's been some movement in the right direction where some recent updates to the codes and standards are starting to address the issue. But for now, smoke containment still isn't a core part of how fire-resistant joint systems are evaluated. So let's take a second to think about how fast can smoke move. Now picture a room that's 8,000 cubic feet, say 20 feet by 20 feet by 20 feet. Now imagine there's just a tiny opening in the wall between the room and another space where a fire is happening, say about the size of a pencil. How long do you think it's going to take for that smoke to pour through that hole and fill the room to the point where you can't even see your hand 18 inches in front of your face? To put that into perspective, that 8,000 cubic foot room that we just spoke about, it can fill smoke to the point of zero visibility. In other words, not being able to see your hand 18 inches in front of your face in about 3 minutes and 40 seconds. It's that fast. So the takeaway here is that while the fire itself obviously is a serious danger, smoke and toxic gases can be just as deadly. And that's why the industry is really putting more and more focus on smoke control, especially how to stop it from spreading from the fire side of a structure into the adjacent unaffected areas. Now, why is it such a big deal? Well, during a fire, the air in the room where the fire starts heats up and expands, kind of like what happens in a hot air balloon. That creates pressure, and that pressure is constantly looking for a way out. So even something as small as a pencil-sized hole can act almost like a blowtorch, forcing hot gases, smoke, and toxic fumes into other parts of the building. It all comes down to pressure imbalance. The fire side builds up high pressure, while the non-fire side is still at a lower pressure, basically pulling the smoke and the heat toward it through any available opening. And this is exactly why it's so important to properly seal all joints, gaps, voids, and penetrations in rated assemblies. These details are really critical for keeping fire and smoke from spreading out of control. So let's move back to the IBC for a minute. Section 715.3 lays out testing standards that Firestop manufacturers have to follow to prove the product performs as required in a rated joint application. Now, this section points to both UL and ASTM test standards. And just a quick note on that. Either one is going to be acceptable for code compliance. However, one does need to keep in mind that whichever lab manufacturer tests will dictate which test method will be used. So while the two are generally similar, there are some differences, especially when it comes to things like L rating, which we're going to touch on in a minute, but when we go over the pass-fail criteria. Now, in order for a Firestop system to pass, it needs to meet a few key requirements. First, must prevent the passage of fire from the fire-exposed side to the unexposed side. Second, it needs to limit the temperature rise on the non-fire side, typically no more than 400 degrees during that test period. And third, it has to accommodate for movement. Now, most joint systems are also tested for cycling, meaning they're put through dynamic movement to simulate building shifts. Now, earlier, I did mention that the assemblies where the rated and non-rated components come together, curtain wall systems being a good example. So in those cases, the rules are covered under section 715.4.2, which does spell out the required testing standards for those types of joints. Another section worth highlighting, 1705.16. Now this one details with special inspections for fire-resistant penetrations and joint systems, and we're going to talk more about that shortly. So let's take a closer look at what ASTM E1966 and UL 2079 actually require. So as I mentioned earlier, both standards are designed to evaluate how well fire-resistant joint systems perform, and they focus on a few critical areas. First, the system has to prevent fire from passing through from the fire-exposed side to the unexposed side. Second, it has to limit the temperature rise on the non-fire side. Now, while 400 degrees is commonly used as a general reference point, the actual requirement is going to be a little more specific. The temperature can't rise more than 325 degrees Fahrenheit above ambient. So if the ambient temperature is, say, 75 degrees, the maximum allowable temperature on the unexposed side would be around 400 degrees. And here's how the test works. After the joint assembly is built and the Firestop products are installed, according to manufacturer specifications, the whole assembly gets mounted to a furnace and then exposed to what's called the standard fire curve. Now from there, the test monitors for two things. If the flames make it through the non-fire side, or if the temperature sensors on the non-fire side register more than 325 degrees Fahrenheit above ambient. If either of those two things happen, the system fails. Now, even though it is a tough test, surviving the fire exposure isn't even the hardest part. The bigger challenge is controlling the temperature rise. And that matters because materials like cotton waste can ignite at or just above 400 degrees Fahrenheit, even without direct contact to flame. So this is meant to simulate real-world risks where things like carpet, curtains, or baseboards on the non-fire side could catch fire from radiant heat alone. Now, in the past, cotton waste was used during these temperature rise tests, but today thermocouplers are used to provide a more accurate reading. Now, once the assembly passes both the fire-resistant and temperature rise portions of the test, it gets detached from the furnace, and then within a specified time window, it's hit with what's called the hose stream test. And we're going to break that down in a moment. Now, earlier I did mention that the fire-resistant joint systems also need to account for movement, and that's a big deal in today's building designs. Joints aren't static, so they can shift due to all kinds of factors like thermal expansion, wind loads, or seismic activities. And these forces can cause the joints to expand and contract and flex over time. And the Firestop systems need to be tested to make sure that they can still perform under those conditions. So to address that, the test standard defines several levels of movement classifications. You have level 1, level 2, and level 3, each with specific ranges for how much the joint moves and how many times it cycles, as you can see here. Now, these classifications are designed to simulate the real-world movement a joint might experience over the life of the building. And it's important to remember that the movement is expected in a lot of places. There are exceptions, of course, but like the bottom of wall joints that usually aren't tested for dynamic movement, but for things like head of wall joints or vertical joints between similar materials, real movement has to be considered, especially in areas with seismic requirements. Now, when we talk about nominal or installed joint width, UL defines that as the size of the joint selected for testing. In practice, it's the opening the system is designed to work with. So the movement capability of a Firestop system is usually expressed as a percentage of that nominal width. So what does that mean in plain terms? Well, the test measures how much the joint can extend or compress from its original installed size while keeping fire-resistant properties intact. So let's take a quick look at how to make this a little more real. So here you see a gypsum wall intersecting the underside of a concrete floor or ceiling assembly. Now the Firestop products were installed with a nominal joint width of 1 inch, and that's the joint size at the time of construction. Now during that movement test, the joint is going to be put through a specific range of motion, and the manufacturer is going to decide how much movement to test for depending on the performance level that they want the system to qualify for. So in this case, the 1 inch joint gets compressed down to ½ inch and then returns back to the original 1 inch. After that, it's extended to 1½ inches. So basically what's happening here is that the joint is going through 50% compression and 50% extension. And the goal is to show that the system can handle that kind of movement, shrinking and stretching, but at the same time maintaining its fire resistant rating. Now, this type of movement simulates what actually happened in the field due to things like thermal expansion, building sway, or seismic activity. And it's a pretty good demonstration of how important flexibility and durability are in real world conditions. Now, to expand on that a bit, let's talk about some of the traditional fire stopping systems, which are often called encumbered systems. Now, that term basically means their ability to handle movement is limited by the physical makeup of the materials used. So for example, many of these systems use Firestop sealants, usually an acrylic-based smoke and sound sealant or spray. Now these products have a very dense composition, and because of the solids and the chemicals inside, there's only so much movement that they can accommodate for. And it's not necessarily a bad thing. These are still code compliant, but they're widely used, and they are widely used in the industry, I'm sorry, but they do have their limitations. So in many cases, these traditional sealant-based systems allow for around 25% of movement in both compression and extension. So let's say you're working with a half-inch joint. That 25% movement rating means the joint could compress by about 1/8 of an inch and extend by another 1/8 of an inch. That gives you a total movement range of just 1/4 of an inch. Now, let's compare that with some of the next generation unencumbered fire stopping products that have come out in recent years. Now, these systems accommodate up to 100% movement. So using the same half-inch joint example, that would mean 1/2 inch of compression and 1/2 inch of extension, giving you a full 1-inch movement range. Now, that added flexibility can be a big deal for designers and contractors, especially on products where movement is a major concern, whether it's from thermal expansion, structural sway, or seismic activity. The key takeaway here is that both traditional and advanced systems are code compliant, but when you're designing or installing, it's really important to understand the movement demands of your joint and ensure the product you select can handle them. Now let's take a step back and talk about the hose stream test. So once a Firestop system passes both the fire exposure and temperature rise, it's not yet done. It still has to go through the hose stream test as part of the full fire resistance evaluation. So here's how it's going to work. A 2.5 inch hose nozzle is going to be used, and the water pressure and duration of the stream depends on the fire rating of the system. So for example, a 1 hour rated system will be hit with a lower pressure for a shorter time than something rated for say 2 or 3 hours. The main goal of the test is to test the durability and structural integrity. In a real life fire, pressure builds rapidly on the fire exposed side of the wall, creating an imbalance with the cooler non-fire side. The hose stream test simulates that pressure and impact, making sure that nothing on the non-fire side gets dislodged or falls under stress. It's also going to simulate real world situations where part of the buildings like ceiling tiles, suspension systems, and things like light fixtures could fall during a fire. That falling debris can hit the wall or joints with force, and the hose stream test helps confirm that the Firestop system and the assembly around it can take that kind of abuse and still hold up. So in short, the hose stream test is really all about providing resilience. It confirms that the system can stand up to fire, pressure, and physical impact, and it still does the job of protecting the building and everyone in it, just as the code requires. Now, circling back to the topic of smoke and toxic gas for a moment. As we touched on earlier, this is the part of the fire protection that is still considered optional when it comes to current fire-resistant test standards. It's not a required pass-fail component in ASTM E1966 or UL 2079 or similar tests. Now, that being said, we're starting to see changes, especially in certain building types. So, for example, in the healthcare sector, places like bed towers, nursing homes, and assisted living facilities, codes are now requiring smoke barriers to be part of that design. Now, these barriers can be either horizontal or vertical, and their job is to break up larger areas into smaller, more manageable smoke compartments, usually no larger than about 22,500 square feet. So say you have a floor plan that's 45,000 square feet. Code would require a smoke barrier to split into 2 compartments. Why? Well, because these types of facilities, you can't always evacuate everyone quickly. Some patients or residents might be immobile or require assistance. And that's where the defend place strategy is going to come in. If there's a fire, you don't evacuate the building immediately. You move people from the affected compartment into the adjacent one where they're protected from smoke and fire. It gives the responders more time and keeps vulnerable occupants safe while help arrives on the fire and the fire side is going to be brought under control. So the smoke barrier is going to be required to do 3 things. 1, resist passage of fire. 2, meet temperature rise limitations. And 3, increasingly limit or restrict the movement of smoke and toxic gas. So to evaluate how well a Firestop system controls smoke, UL developed the L rating test. And this was the first standard to specifically measure a system's ability to limit air leakage, which is used as a stand-in for how smoke might move through a joint penetration. Today's L rating is commonly applied to Firestop systems used in smoke barrier assemblies. Now, we've already talked about how this is important in healthcare settings, but correctional facilities are another big area where the defend-in-place strategies are required. In both of these building types, L rating Firestop products are now expected when smoke barriers are part of the design. And while the L rating is mandatory for smoke barriers, it still isn't mandatory across building types. However, there is a growing awareness in the industry about its importance and momentum toward expanding its use. Now, whether it becomes a universal code requirement, that's still up in the air, but in high occupancy environments where evacuation isn't easy, it does represent a real step forward in life safety during a fire. Now, shifting gears, let's talk a little bit about what the building code says about special inspections. So back in 2012, the International Building Code introduced special inspection requirements for the first time. And you'll find the current language in section 1705.16, which lays out what these inspections involve and when they're required. So in the simplest terms, special inspections are now mandatory for certain types of construction. And this is going to include high-rise buildings, risk category 3, structures like large gathering spaces, risk category 4, essential facilities like emergency response buildings, and starting with the 2018 code cycle, Group R, and these are residential buildings that house more than 250 occupants. Now, if your project is going to fall in one of these three categories, and your local jurisdiction has adopted this part of the code, then your fire-resistant joint systems and penetrations must go through special inspections. The goal of these inspections is to verify proper installation and make sure everything is done according to the test and approved fire stopping systems, and that's something we're going to dig into next. Under the special inspection provision, the authority having jurisdiction, or the AHJ, usually the local building official, he has to approve a qualified special inspector. Once that inspector is on board, they'll evaluate the fire stop systems using a nationally recognized standard, specifically ASTM E2174 for penetrations and ASTM E2393 for fire-resistant joint systems. Now, when it comes to ASTM 2393, there are two main ways an inspector can assess joint installations. One is via visual inspections, and this is going to involve randomly observing 5% of the total linear footage of each joint system as it's being installed. Or you can go with the post-installation destructive testing. Now here, the inspector performs a physical test on one sample for every 500 lineal feet of each joint system after it's been installed. And here's the important detail. Notice the phrase each joint. And that matters because it's easy to overlook how many different joint types can exist in a single space. So for example, in just one room, you might have a head of wall joint, a bottom of wall joint, a vertical joint where the wall terminates into a concrete column or CMU, and possibly even wall intersections or bulkhead joints. Each of these is treated as its own joint system, and each one must be inspected separately, either visually or with destructive testing. It's also worth noting that these inspections are not a one-time thing. The standard requires them to be repeated every 10,000 square feet of the building footprint. So in a large structure with a variety of joint systems, the process can get pretty involved. And that's why it's so important to plan ahead and schedule these inspections early in the construction process so they don't hold up the project. Finally, always make sure to check with the local building code in the area where you're working. Now, many jurisdictions have adopted these special inspections requirements, but not all have. The trend is definitely moving in that direction, but it's always best to confirm with the local AHJ at the start of the project. So let's take a look at some of the first generation fire stop systems. These have been around since the late 80s and early 90s. Now, the early solutions are often called wet applied systems, and they include the traditional sealants and sprays that were developed as the industry started to really understand how important fire stopping is for compartmentation and life safety. Now, most of these products are acrylic based, especially when used as sealants, but you'll also find silicone based options as well, which tend to offer more flexibility. The movement capabilities of any given system really depends on the base formulation. In general, silicone does provide more movement than acrylic, but performance can vary a lot between different products and manufacturers. And you can see an example in the image, a typical head of wall joint where a gypsum wall meets the underside of a concrete deck. Now, in this kind of setup, the sealant has to be applied with the right depth and thickness, exactly as specified in the manufacturer's UL listing. And the big takeaway is this: the movement capability is specific to the product. So if you're working on a project where the joint movement is a key concern, it's critical to check the tested and listed Firestop systems to make sure that the product can handle the performance demands. Now, another widely used product in this category is Firestop spray, which has become a go-to solution across the industry. And while it's most commonly used in fluted deck applications, it can also be applied to concrete decks in certain situations. So here's how it typically works. A packing material like mineral wool is first installed into the joint. Then the Firestop spray is applied over the top, following the detail in the tested system. Now, these sprays are usually applied at a wet thickness of about 1/8 of an inch, and then as they dry, that shrinks down to about a 1/16 of an inch. And thanks to the formulation, the Firestop spray may offer slightly more movement in terms of compression and extension than traditional sealants would. And that being said, the actual movement capability still depends on the nominal joint width. So in the image shown, that nominal joint width refers specifically to the space between the top of the gypsum board and the bottom of the fluted metal deck, not the height of the flute itself. This joint width is often somewhat between 3/4 inch and 1 inch, depending on the assembly. And the flute fill in the middle of the image is not part of the measurement, and that's an important detail. The test standards are designed to apply maximum stress to the narrowest part of the joint, because that's where the Firestop product is more than likely to be stressed during both the cycling and the fire exposure. So the performance rating is based on that primary stress zone, not the full depth of the flute. Understanding this distinction is critical when evaluating or specifying these systems. Now, in recent years, Firestop solutions have continued to evolve, especially in response to the growing demand from specialized building types like data centers, for example. These facilities often need significantly more movement capabilities at head of wall joints, sometimes up to 4 or 5 inches of total deflection. And so to meet those demands, the industry developed innovative framing designs, including what are commonly called T-shaped tracks. Now, these were part of the first generation solutions designed specifically for high movement joint applications. And while the concept itself isn't new, we're still seeing a renewed interest in these systems and more high performance buildings come online. Now, these T-tracks assemblies are still widely used today. They're code compliant, effective, and they're readily available. The design features a horizontal shoulder that supports the gypsum board, allowing it to float on the inside of the track as the building moves. On top of that, the metal cover plate are installed over the face of the gypsum board. These plates are either contour cut to match the profile of a fluted metal deck, or flat cut to align with the concrete deck, like you see in the images to the right. Now, one of the biggest benefits of these systems is their enhanced movement capability. Many of them are rated to handle up to 100% compression and extension, making them ideal for head of wall conditions where you expect large deflections. So whether you're designing for a data center or any structure with demanding movement requirements, these tested and accessible systems offer a reliable solution that helps bridge the gap between performance and practicality. Now, we're now seeing the industry shift towards what is called the next generation of Firestop solutions, commonly referred to as preformed firestopping products. Now, more and more manufacturers are offering these systems because they address today's construction challenges in a way that's faster, cleaner, and more consistent with older methods. The key difference is that these products are fully cured before installation, which eliminates a lot of variability you'd run into with like a wet applied system. So for example, in the CEMCO line of Firestop solutions, the materials might be foam-based or vinyl acrylic-based, and most of them incorporate an intumescent strip into their design. Now, if you're not familiar with intumescent, think of those little novelty fireworks, the black snakes that swell and expand when lit. That same idea applies here. When exposed to fire, the intumescent component is going to expand inside of the joint, sealing it off to block fire and smoke. Now you can see an example in the bottom right image, which is Fire Gasket, one of CEMCO's preformed solutions. On the back of the vinyl flange, there's an integrated intumescent strip, so that when it's exposed to fire, it expands and fills the joints, delivering code compliant performance while still allowing for joint movement. Bottom line, these preformed systems offer a cleaner, more reliable, and more efficient alternative to traditional wet applied Firestop methods, and they're quickly becoming a go-to choice for many modern projects. And here's a good example of fire gasket, which shows how it's actually installed and how it performs in the field. Now the product has an adhesive backing that sticks right to the vertical leg of the track, whether it's slotted or solid. Once that's in place, the gypsum board goes up and over the gasket, usually centered along the leg, so you get a full coverage and reliable performance. The fire gasket is going to be available in 3 sizes: 1/2 inch, 1 inch, and 1.5 inches. And it's suitable for both 1 and 2 hour rated wall assemblies. And watching the installation video, you're probably going to notice that the system isn't just about fire protection. It also handles drift and dynamic movement very well. It makes it a solid choice for seismic applications or for projects in regions where structural movement is something that the design team has to plan with. So let's talk about another category of next generation Firestop solutions. Those that don't just attach to the leg of the track, like fire gasket, but actually integrate with the drywall itself. And a good example of this is going to be Hot Rod XL, which you can see in the images here. Now this product has a pink perforated mud leg that's installed right onto the face of the gypsum board. In the joint between the top of the drywall and the underside of the deck, you've got a compressible foam gasket, plus an intumescent strip that expands when exposed to fire, sealing off that joint. Now the slides here show the system from start to finish, and one of the biggest advantages of this type of solution is how clean it looks when it's completed. That makes it especially useful in projects with exposed ceiling condition. Think hotels, condos, or residential high rises where the joint is going to be visible. Often the exposed or skim coated deck is the finished ceiling. So using a solution that delivers both code compliance and a flawless look always means big savings in time and labor. Now, the built-in bead serves as a finish edge, covering the exposed top of the drywall. And after the installation, the joint gets stapled and mudded, and then the zip strip is peeled away, leaving a crisp, seamless edge. This provides a code-compliant, fire-rated, and aesthetically pleasing result, meeting International Building Code requirement. And as a bonus, these systems help with sound performance, contributing to the STC ratings. Another reason why they're a great fit for multi-unit residential and hospitality projects. So let's take a quick look at a recent code update that's important to call out. Now, in both the 2018 and 2021 editions of the International Building Code, section 715.6, that was added and then refined. Now, this section focuses on how we treat vertical joints where the fire barrier meets an exterior facade of a building, like where the wall runs into a glass curtain wall, as you can see in the image here. Now, to meet this requirement, there are now several product solutions available. The one we're showing here is a CEMCO system that's been tested to the current UL 2079 standard, which is what the code requires. Now, although 2079 is the industry test standard for this detail, I do want to note that ASTM work group has recently introduced a new test method to committee E1505. Now, that proposed standard is under review and will likely be adopted soon. Once it is, the manufacturers, including CEMCO, are going to be retesting the systems so that they align with the updated ASTM protocol. Now, the specific solution in this example uses a CEMCO Super Seal X, which in this case comes in a black profile to better blend in with the curtain wall system. Behind the gasket, there's a metal sheet angle fastened to the last vertical stud that extends outward toward the glass, maintaining about a 1/4 inch gap from the glazing. Now, the Super Seal X itself has a bubble gasket that presses right up against the curtain wall, providing a clean, discreet finish. The black color helps it visually disappear into the facade while still delivering critical performance of a 1 or 2 hour fire rating, plus tested for STC and for sound. So with that system, you're not just getting fire and sound protection, but you're also getting a refined, professional looking interface where the fire rated wall meets the building envelope. Now this is FireRip. It's a solution that was developed in response to the growing need for high movement fire rated joint systems, especially in data centers and other critical infrastructure projects that we see going up around the country. Now, the T-shaped tracks have traditionally been the go-to option for handling movement, and they're still a viable choice, but they do come with their challenges. Each T-track has to be custom made to match the stud width, whether it's 3 5/8, 4 inch, 6 inch, or 8 inch. So you end up needing a different track for each condition. And that makes procurement more complicated and can add to extra lead time. FireRip was designed to solve that problem. It offers comparable movement capacity up to 4 inches of total deflection, but with far more flexibility and ease of installation. Because it's surface mounted, it works with any standard track, whether it's slotted or solid, and isn't tied to a specific stud width. That versatility makes it a great fit for a range of assemblies, from CMU walls to shaft walls to standard gypsum partitions. It's essentially a single profile solution that attaches right to the underside of the deck, which really helps simplify both installation and inventory. If you're looking at the photo on the bottom left, you'll see an example of fire rip installed under a fluted metal deck. And one important benefit here is that when paired with mineral wool insulation, the UL system allows the mineral wool to be compressed directly into the flutes without needing any extra Firestop sealants or sprays on the face. At CEMCO, our focus goes beyond just meeting code. We're also committed to creating solutions that reduce labor on the job site. And with our close ties to the drywall industry, we do put a big emphasis on products that save time and simplify installation while still delivering proven performance. And Fire Rip is a great example of that balance: code compliance plus labor savings. So with that, let's shift the topic a little bit, and rather than talking about the products, let's take a look at the construction documents, specifically what we tend to see out in the field. I'll also share a recommendation for the design professionals in the audience. Something you may already be doing, but if not, definitely something worth considering. So on the left-hand side, you'll see a pretty typical partition detail. And a lot of times we'll come across exploded views like this one. And they're really helpful because they do show the structure, joint conditions, and overall construction methodology. Now, these drawings usually come with call-outs or references to support details, which help give everyone a clear picture of what the specific requirements of that assembly. Now, this is an example that comes from a project that our product manager worked on not too long ago. And in this case, the design documents show 3 different joint widths: a 3/4 inch joint for a non-rated or smoke partition, a 1-inch joint for a rated partition, and on the same sheet, a CMU head of wall detail with a 1.5-inch joint. Now, why does it matter? Well, it matters because if you follow the details exactly as drawn, you'd end up with 3 different wall types, each with a different joint width. Now, on paper, that might work, but in practice, those walls often intersect. And when, say, a non-rated wall with a smaller joint, but into a rated wall with a larger joint, the smaller joint can actually act as a bump stop, essentially cutting off the rated wall's ability to move as designed. That means the rated wall might not achieve its intended deflection capacity, which could create issues if the building experiences movement. So the takeaway here is very simple. From a design standpoint, it's really important to develop coordinated, standardized joint details across all wall types. That way, when different assemblies meet in the field, they don't restrict each other's movement, and the entire system can perform as intended, in line with the building's deflection and seismic design criteria. Now, from a construction documents perspective, let's take a minute to talk about specifications. The section we most commonly see for fire-resistant joint treatments are 078443 and 078446, which specifically deal with joint fire stopping. Lately, though, we are starting to see some movement towards 078400 being used as a large catch-all section that covers all fire-resistant joint and penetration applications. Now, that being said, 0843 and 0846 are still very much the industry standard. We're also noticing more activity around 079200, especially for acoustic joint treatments. Traditionally, acoustical sealants were lumped in with 079200 joint sealants, often alongside exterior architectural sealants. The challenge is that exterior sealants requirements, things like adhesion and movement, are pretty different than what's needed for interior acoustics. And so because of that, we're not always seeing more specificity. Subsections like 079219 or 079216, which call out acoustic joints directly, are becoming more common. At CEMCO, our goal is to be a technical resource for those working on design and specifications. And that might mean helping standardize partition details like what we talked about earlier, or assisting with specification language. Now, while of course we'd love to see our products called out directly, we do understand proprietary specs aren't always possible. That's why we're happy to provide non-proprietary performance-based language that works for preformed solutions in general, no matter which manufacturer's product is going to be used. Now, shifting to sustainability. The most common question we get asked is, do these products contribute to LEED certification? And the short answer on that is going to be, it just depends. Contributions to LEED varies by manufacturer and comes down to the material formulation of the product. So for example, with wet applied Firestop products, the UL follow-up service requirements are pretty strict. These requirements often limit the use of recycled content since the chemical composition has to stay tightly controlled. Recycled content is difficult to control in the mix when manufacturing sealant formulations, thus making it difficult to maintain consistency. Now, on the other hand, preformed products, like many in the CEMCO line, tend to offer more flexibility. So in our case, the vinyl legs and foam gaskets aren't the active fire-resistant component. That gives us the ability to incorporate recycled content, which can help support LEED-related sustainability goals. Now, that being said, whether you're looking at CEMCO or another manufacturer, our advice is always the same. Check directly with the manufacturer to confirm what sustainability documentation or LEED contributions are available for a specific system. So summing things up, our goal today was to highlight some of the new technology shaping the industry, especially preformed fire stopping solutions. Now, these systems are quickly gaining traction, and for good reason. They do bring real advantages over traditional methods: better consistency, easier installations, and reliable performance. That being said, it's important to remember that both preformed and conventional fire stopping methods can be fully code compliant. The real key is just to make sure that the solution that you choose, whether it's in design, specification, or installation, fits your project requirements and supports the long-term safety, efficiency, and durability. So with that, this concludes the presentation. I'd like to sincerely thank everyone at AWCI for their continued support of the presentations like this one, and also would like to extend my thanks to everyone who's attended here today. So I'll hand it back off to Tao and open it up to any questions you might have.
Thank you, Jaime. Did one of the slides state that CEMCO's product installed in a fluted metal and concrete deck application do not require fire sealants or sprays to cover the mineral wool flute plugs?
Yes, actually, that is correct. That would be the fire gasket product that we looked at. There are no sealants or sprays that are going to be required, and you can actually use flute plugs in the flutes as long as the mineral wool is compressed to 33% compression.
I think you mentioned this before, but can you speak about it again? What is the largest joint width fire ripped can be used?
Sure, yeah. The largest joint width is going to be 2 inches, so it will provide for an overall 4 inches of total movement, 2 inches up, 2 inches down.
Next question here, is the CEMCO mullion solution using the SuperSeal X product a new UL system?
Relatively new. It was tested over a year ago. If you look at the assembly configuration, if you pull it up, which is WWD0182, it does show 2 products on there. One we no longer manufacture, and then we have, if you look under configuration B, that does call out SuperSeal X. And although it is shown abutting a wall, due to the fact that we could not test it with the glass, we are able to promote it as butting into the glass, because that's the intent of having the window mullion.
Are CEMCO products manufactured in the US and Buy America or Buy American compliant?
So good question. The answer to that is yes. Regarding the Build America, the CEMCO products do comply with both. However, one of those is a little more stringent than the other one, but I'd be happy to talk to you about it offline and provide more information on that.
Great. Do the preformed fire stopping products contribute to STC ratings as much as or more than the encumbered first generation system?
You know, the totality of the wall assembly itself is what's going to provide the STC rating. So per se, if you have a certain number that you're trying to achieve, our products will achieve that STC rating with that.
Thank you. And last question here, why recommend having project documents define joint widths and movement requirements?
You know, it's a good question, and this is the best way to do it is really provide an example. So let's say you're looking at a blueprint that shows a 3/4 inch joint using a sealant that's going to provide roughly, say, about 1/8 of an inch of movement. Now, down the road, after the project has already been bid, you might find out that the structural engineer wants a 1/2 inch of movement. Well, now you got to go use a different product and possibly one that's more expensive. So it's always important to understand your starting point and what type of joint movement is going to be required.
Thank you. Actually, a couple more questions just came in, so if you can hang on a minute. As a building owner with some of the first generation system that were installed a decade ago, should I be worried? If so, what should I do?
Honestly, since we do not handle the first generation products, I think my recommendation would be to contact the manufacturer directly if you have their name and follow up with them.
Thank you. And here's the last one. Effectively fire stopping, as UL Design says, a wall with a classical product, non-STC rated fire stopping product, could reduce its acoustical isolation?
That's a good one. I will actually have to check up on that one. What is it that they're trying to, or what are they asking, I guess?
I think it's fire stopping. Does it reduce acoustical sounds or anything like that with fire stopping? Something along that line.
No, it does not. Our products, you can achieve an STC, as we talked about earlier. You can achieve an STC rating using our products, or they can be used in an STC rated assembly.
Great, thank you. And if that didn't answer your question, the asker, please reach out and we can clarify that some more.
Yes.
Well, thank you. That concludes our Q&A session. Thank you so much, Jaime. Thank you to CEMCO for sponsoring this webinar. And thank you to all the attendees who joined us today. We'll see you next time. Have a good rest of the day. Bye now.